Welcome to Eric's Guitar Amplifier Repair here in California. My name is Eric. Today on the test bench we have two beautiful McIntosh 240 power amplifiers. These amplifiers can be played in a stereo circuit design and in a monoblock circuit design. Monoblock, we have two. These are fantastic amplifiers. As a matter of fact, these two amplifiers are the best amplifiers that have come across my test bench in 30 years. We will reform the can capacitors. We will rebuild the bias circuit. We will replace all the electrolytics in the general circuit board. And we will replace any components that have failed. Let's begin. Okay, so we're looking at the McIntosh 240. We have the enclosure taken off and we can see the circuit board. I want to remind those technicians that are just starting out or those who are just repairing their amplifiers on their own, please test the tubes, test the vacuum tubes first. Do not apply power to your amplifier even if you're using a Variac. You want to check the vacuum tubes first. In this case, all of the output tubes were blown, they were no good, and 3 of the preamp tubes were also not passing, they were failing. Output tubes failed and 3 of the preamp tubes failed. When looking at the circuit board, all you need to do before you do anything else once you test the tubes is just do a visual inspection on the board, on the circuit board. What jumps out to me right away is that we have what's supposed to be a 12K at 2 watt resistor. We have I don't know what this is. It looks like brown, red, and yellow. This should be brown, red, and orange. These both should be 12K resistors. The reason why this is looking the way that it is because this resistor is fried. It's actually overheated and it gotten so hot that it looks this color. My suspicion is something's going on with the bias circuit, and we'll look at that in a moment. But assuming the bias circuit was fine, you would test the negative bias voltage, which is negative 48 volts. And it'll go up to 50, 60, 100 volts. You know something's wrong. So that's why it's good before you apply voltage, you test the output tubes, you do a visual, you see what jumps out at you, you replace this right away, and then you can go ahead and start replacing the electrolytic capacitors. In most cases, I found that you can reform the electrolytic capacitors the can type. Let me emphasize that, the can type. This is just adding voltage slowly, but nothing's going to help your capacitors unless all of your circuit board and other components are okay. Moving on, let's turn this around. If I can here, let me see if I get you in the shot. So I've already replaced these electrolytic capacitors. These are the Sprague & Adam, which I really like. This is 100 ohm at 100 volts, 100 ohm, 100 microfarad at 100 volts. So these will be replaced, these two here, and then turning this amplifier around yet again. There we go. And you can see that I replaced both this electrolytic capacitor at 22 microfarad at, what is it, 500 volts. 500 volts. This is a 22 microfarad. Also below that is a 0.01 microfarad capacitor. Now this capacitor that I replaced had continuity, right? So the previous Bumblebee capacitor had continuity going through it. It was like just having a wire. This is why the amplifier was blowing fuses. This is a critical circuit in the power stage, and that's why these were that's why this was, you know, blowing fuses and just pulling current straight to the ground. Not good at all. I found that the diodes in these types of amplifiers work fine, and you can test them. They're no problem, easy to test. This is a Selenium Rectifier. This is the original, I think, Selenium Rectifier, although it looks like somebody came in and monkeyed around in here. So I don't know if that was another technician or that happened at the factory. I would think that this did not happen at the factory, so somebody played around with this at some point, maybe trying to troubleshoot it themselves, and then sold it when they couldn't figure it out. This is purchased from a customer of mine, and I believe he hasn't touched anything, so I know it's not him. In any case, these tend not to fail, these diodes. The Selenium Rectifier, I have never had a Selenium Rectifier fail on me in the 20 years that I've been working on amplifiers. I have an amplifier by H.H. Scott that uses Selenium Rectifier. I've rebuilt that whole circuit, although preserving most of the components, carbon composition, so on and so forth. Never had a problem. I play that amplifier every day, so these tend not to fail. Now I hear on the internet that you have to replace these always because there's always failures there. I haven't seen it yet, but I don't think it's a problem. Don't be afraid, and let me emphasize this one more time. Don't be afraid to rebuild the bias circuit. Don't be afraid to rebuild it. That's fine. If that's what you want to do, totally fine. You'll have to make an adjustment here. If you do replace the Selenium Rectifier, what you're going to do is you're going to have your diode facing the negative, or the voltage goes in, positive voltage goes in this way, in this direction. So you want that stripe, that negative looking stripe on the diode to go this way. You're also in series are going to want to put in a 470 ohm resistor. You can use a 1 watt. I think that's fine. Middle film is fine. So you're going to put your diode in, and then also connect a resistor. In fact, let me show you what I'm talking about here instead of trying to explain it. So let me see. Here's an example. So we have your diode. It's going to go in this direction. This stripe goes this way. This is a reference you can use as the positive side of the capacitor. That stripe can go on the positive side. Okay, voltage is going this way. Then you're just going to tie in a 470 ohm resistor. This will get you right at negative 48 volts, no problem. We'll move on. This is the second McIntosh 240, and we're looking at the bias circuit, and you can see here that we have this Selenium Rectifier. This, I am confident, is not the original factory Selenium Rectifier. It looks like someone came in and hooked up the wire to here, and my voltages were too high at pin 5 of the output tubes. So this is a good candidate for the diode and 470 ohm resistor in series modification. So we'll do that. Now I think the 470 ohm is a little bit still too low. So I'm going to try to figure out a higher value, and I might just throw in different values and find the proper voltage drop for this particular amplifier. Wanted to point out this section here. There's normally a thermistor here. This is a component that's used to minimize the inrush of current. Someone clip that out and tie these two together. Very bad idea. When you power up this amplifier, there's no on and off switches. Just plug it in. You'll see your whole house light drop for a second, or more. And that's because it's pulling so much current. It's drawing dangerously high currents. This will blow out the output transformer and just cause a lot of problems. So don't do this. Don't cut out the thermistor and tie it together. It's a very bad idea. So we ordered a thermistor for this. Alright, so we're looking at the McIntosh 240. I have two of these that are in for service, and we went ahead and replaced the bias circuit electrolytic capacitor, this snubber capacitor, 0.1 microfarad. We kept the rectifier. This is a Selenium Rectifier. The positive side is going in this orientation, positive orientation. The diodes have not been replaced. Again, you can see somebody came in and monkeyed around in here. Had to cut it out and maybe put it back in. I don't believe this one looks like from the factory. This one looks like somebody monkeyed around in here. I know somebody tried to do something with this and ended up blowing the fuse. So this has been rebuilt. All of the output tubes had failed, so we have new tubes in here. I'm now getting negative 46 at pin 5 of the output tube. That's exactly where we want to be. I'm going to turn this around and show you that when I originally replaced the bias circuit, I was getting some weird voltages, and this was because this resistor had been fried. It was measuring 6 kilo ohms, and it should have been 12, so we replaced that with a 12 kilo ohm at 5 watt. This is measuring 12 kilo ohms on this side of the channel, and then down here we're measuring 17 and 17 here. I guess it's sort of within tolerance. I may replace these two because I'm getting some weird voltages here. Now, moving up, we have these coupling capacitors here. This one's measuring 0.022 microfarad. This is measuring, I don't know, 1 microfarad, or there's something going on with this coupling capacitor. These two capacitors are known to fail, so I'm going to have to replace these. I'm probably going to use the Selenium capacitor because it's a little bit smaller. The footprints, going to fit in here, and it'll sound fine. These are paper and oil. I could use a paper and oil Russian military type, but I think I'm going to, since not too much voltage goes through these, I'm just going to use the Solon. It'll sound fine. So that's where we're at this point, but I already played music through this. Sounds pretty damn good. These particular type of power amplifiers are known for their rich bass sound and their beautiful mid-range and their high-end, and it's actually emulating that as we speak, but there were a few problems here, so we're going to continue replacing parts that need to be replaced. So we'll show that in the next segment. Okay, so we're looking at the McIntosh 240. This is amplifier A. I have two McIntoshes here at the shop. So this originally had a Selenium Rectifier. I did choose to remove that rectifier. It looked like somebody had come in, took it out, put it back in, and now I'm taking it out. And this is because the voltage at pin 5 of the output tube was reading around 49 volts, so I wanted to get it at 46 volts. So it's an old amplifier. You know, the resistors are not exactly in tolerance, they never were, and so most likely this voltage gain is probably due to resistors. They tend, as they age, the Allen Bradley resistors tend to age, and as they age, the resistance goes up. So we're just making adjustments based around the age of the components of the amplifier. We don't want to replace everything in the amplifier because this particular amplifier uses the Bumblebee coupling capacitors, and these are paper and oil types, and paper and oil capacitors sound really nice, and people really like to hang on to the Bumblebee stuff. Now, I did replace these two coupling capacitors in the output stage, and I used these Mojo Tone. Now, normally I would use Russian paper and oil, the military type. I like those. However, the balance wasn't right. It was a little bit too bright, too tribally for me. So I chose the Mojo Tone. These are the mustards, I believe. This had a little bit more rounder sound. It matched the other coupling capacitors, and I'll show you those now. That would be these here. And let me get some more light on there if I can. So it'd be these two. It would be probably better to just replace all of these, but again, I really want to preserve this amplifier as opposed to rebuild it and then it changes the sound. Granted that with the McIntosh, a lot of the awesome sound that people love really comes from the transformers because they're built in-house and they were pretty consistent with their build quality and their revisions. They didn't revise too much unless they had to, and that's what is usually the problem when manufacturers, you know, people say, oh, I need to get a 1960s McIntosh, and then they reissue one that's the same in the modern time, and they say, oh, it doesn't sound the same, but that's because manufacturing techniques change, and components and wires and all that kind of stuff all change the way that they're manufactured, and that's why people like the vintage stuff, because they were built a certain way with really good build quality. So anyway, that's that. I'm sorry I'm rambling on here. I do want to show one more feature here, and that is I did put some Solon 0.1, was it 0.1? What did I put in here? Yeah, 0.1 microfarad Solon capacitors in this bias stage. These tend to always fail, and I don't know why, because there's not a lot of voltage going here, but they always tend to fail, so I replaced those as well. And we're going to button this up. The amplifier sounds fantastic. It sounds really balanced. It's probably the best amplifier that I've heard so far. Now, this is just a power amplifier, but it does sound really amazing. So we're going to button this up. I do want to clean the potentiometers. I did already one pass. I'm going to do a second pass, and then just do my usual clean the all the tube sockets, and we'll do one more test, and then we'll button that up, and then we'll move on to the next amplifier. The next amplifier is going to be an interesting one. I do want to make one more highlight before I end this part of the section of the video. And that is, and I'm going to try and get right in here. Let's see if you can see this. And we're looking at this here. I don't know if you can see that. Let me get some more light on there. So this is a thermistor. This is what helps the inrush of current. It limits it. On the other amplifier, someone cut this out and tied these two wires together, and when I powered it up, I didn't notice it, and when I powered up the amplifier, you could see the lights in the shop drop, and I was like, uh-oh. And so I knew at that point to shut off the amplifier. Again, this was put on a variac, and I recommend everybody to always use a variac when they're first powering up, or during the replacement of components. Just use a variac in the beginning. And we put this thermistor in here. This is a 20 ohm thermistor, 20 ohm, and the other amplifier has, like I said, them tied together, so we'll show that process of putting that in and so on and so forth on the next amplifier. Alright, so we'll move on to the next section. So here's the McIntosh 240. This is A. This was covered in a thick layer of dust. We had paint specks all over the chassis, front panel, so on and so forth. So I hit this section here with car wax. I hit this section here. Let me see if we can get that in the shot, with car wax as well. This is to preserve, again, we're preserving the amplifier. We're not doing a full restoration. We want to preserve, because most of the magic in these McIntoshes has a lot to do with the original components, i.e. carbon composition resistors and bumblebee paper and oil capacitors. You can see here that all the output tubes have been replaced. We have 2 preamp tubes, 12AX7s. I think this one was replaced as well. Let me see. She's gonna come off here. Yes, 3. So 3 12AX7s were replaced. 1, 2, 3. I used the JJ tube. This is a preference of mine. The chrome, I just use Windex to clean up the chrome. Again, we're just trying to preserve. I use a probe to scrape off all the specks of paint. And so this is what it looks like. It's a very nice looking amplifier. For those audiophiles who are looking for the ultimate power amplifier, this is it. These amplifiers go from between used 4,000 to 10,000. These are sought after by collectors, record producers, audiophiles, and collectors. So this is a very nice piece of equipment. I highly recommend anybody who inherits one of these, finds one in the trash, so on and so forth, please rescue the amplifier. Put it on eBay if you're not into audiophile. If you're into audiophile, consider yourself lucky. If you see something like this on Craigslist in your local area and they're only asking for a few $100 or $800, even $1,000, it would be a good idea to rescue the amplifier. Take it to your local technician and they will preserve and or restore the amplifier, and you have one of the best amplifiers ever created in the world. They are fantastic amplifiers. There's no magic in the amplifier per se, because it's a tube amplifier. It's just that tube amplifiers are very linear. The magic in this particular McIntosh has mostly to do with the transformers. The transformers are wound in-house and they're used to the best quality, and you can do the research online about the amplifier, but these are the best in my opinion, and in everybody's opinion, I think. So that's that. I'm going to go ahead and put the tube cover on just to give you a sense of what that looks like. So there's that. And then I'll get a quick shot of the front. Now let me move this. These are about 50 pounds, so give me a minute to get the front shot, so please hold. And here we have the front shot of the amplifier. Again, this was covered in little specks of wall paint that's been removed. We just cleaned the chrome cover with Windex. We just want to preserve the amplifier. All of the tube sockets have been cleaned with deoxit, including the potentiometers and this switch here as well. Really amazing components on this. We also cleaned with deoxit these speaker terminals, and this came in again blowing fuses. We rebuilt the bias circuit, all the electrolytics, not the can type, but the basic electrolytics on the turret board were replaced. The original electrolytic can capacitors are still in this amplifier. We were able to reform the capacitors, and this amplifier sounds really fantastic. It's just an amazing amplifier. I do recommend that you use this amplifier in the stereo pair as opposed to taking two of these and making them into mono blocks. You have a switch for that. You can do that, that's fine. It sounds fantastic again, and it's got its own gain switch for each channel. And then you're going to have one left side's going to go on here and the right side's going to go here. It's just a fantastic amplifier in general. But again, I do recommend just using the stereo section of this because of the way that the amplifier is designed. They did a great job. Side note, these output tubes, normally you would have your technician bias the amplifier each time he changed the tubes. McIntosh created a specialized circuit that allows you to change the output tubes without having to rebias. Okay, so the bias is set when you rebuild the bias circuit by your technician. Then after that, you can just keep replacing the tubes. Again, a fantastic amplifier. It's just very rare to have an amplifier like this in your position. It's, I feel very fortunate about having these types of amplifiers coming into my shop, and I get to enjoy some of the world's most sought after, the best amplifiers, whether they're guitar amplifiers from Fenders from the 60s, and audio components like this McIntosh 240. Really amazing amplifier. Side note, the feet on this amplifier has been changed with, not this one, that's the old one. The feet have been changed with this type provided by the customer, and he did his research. Good job on his part, and got what looks like the original McIntosh type feet. So these have been replaced. So yes, a beautiful amplifier. And that's the end of the McIntosh 240A. I'm going to bring in the second amplifier that is a McIntosh 240, and we're going to call that B, amplifier B, and we'll go through the process of what was changed again. So let's move on. Alright, so we're looking at the McIntosh 240. This is amplifier B. Somebody cut out the Thermistor. This is a current reducing component. This is what the original looks like. Get a better shot of that there. So somebody cut that out. This is from the Amplifier A. I replaced this with a 20 ohm. And the reason why is it's cracked and it's arcing, so we replaced that. But somebody cut this one out here. They cut it out and they tied these two together. That's a really bad idea. You're just going to end up destroying your amplifier. Please don't do that. Other technicians out there, don't do it. It's not good. So we will replace it with this. Here it is. 20 ohm thermistor. This is the McIntosh 240. This is the McIntosh B. I wanted to highlight this circuit board. Look at this. This is an incredibly done assembly here. We have these carbon composition resistors. All of them are carbon composition. And I believe this has a lot to do with that warm sound that you get from the McIntosh product. So I want to bring up a little bit of an issue that we had here. This is the final test, and we did a 1 kilohertz injected into this amplifier at 1 volt and then 2 volts. And I found that one of the channels had a higher amplitude than the other, so I traced it back and found that with this stereo potentiometer, one section had 100K, which is what it's rated for, and the other section had 50K. So it's the natural response is to purchase a new potentiometer at 100K. Now I found that when I measured from this lug to this lug, this was 100K, and then this lug from this lug, this was 80K. So kind of back to the same problem. So what I chose to do instead is see if I could clean this section of the potentiometer using the oxide. So you just sit there and clean it and turn the knob back and forth. What you do is while you're doing that, you hook up your voltmeter and set it for ohms. And you'll see that as you're cleaning it, the resistance goes from 50 to 55 to 60 and so on and so forth. At this point I got it up to about 76 or 78K. Did another injection, but measured on the oscilloscope the 1 kilohertz injection right at the lug, and it seems like it's a little bit more balanced. So instead of taking this apart, we're just going to leave it, and then we're going to do a sound test because the ears are the best tool you have as far as detecting issues, as far as balance problems and other issues like that. So this is I think a good solution to this problem. And I'll assume that as time goes on and as this is played more and more, and this may clean itself to the point where it's more balanced up to at least 90K. So hopefully this is helpful for you technicians out there. We are looking at the McIntosh 240B. We are calling this B because we received two McIntosh 240s at the same time. McIntosh A has been received by the customer, so let's get this B out the door as well. Bias circuit's been replaced. Electrolytic capacitors have been replaced. We reformed the original can capacitors. Lots of new output tubes and some preamp tubes as well. We can see all of the bumblebee capacitors here. These are all paper and oil. We had some issues with the balance potentiometer. We used a little bit of solvent and then lots of deoxit to fix that issue. We are back at 100K on both channels. We have negative 45 bias voltage on pin 5 of all of the tubes. We're looking at negative 46 volts bias per the schematic. We'll take a look at the sine wave next. So we're looking at a 1 kilohertz sine wave injected into the McIntosh 240. Now I'm looking for two things here. The first thing I'm looking for is, it turned out I had to change the balance potentiometer. This was a 100K stereo, and I needed to know that it was functioning properly, and it is. And the balance is straight 12 o'clock, so this is a nice signal. The second thing that I'm looking for is, I'm looking for distortion in the sine wave, and this is due to the fact that instead of replacing the CAN capacitors, we reformed the CAN capacitors. And you can see we just have this really nice clean sine wave, both channels, exact amplitude. This is amazing. This is an incredible thing to see with an amplifier that's 50 years old, with CAN capacitors that are 50 years old. This it's just astounding to see this kind of quality in a build back in the 50s. This is something that is lacking in our current manufacturing.